Good morning to all. As we discussed in the beginning, Unit 1 is divided into two parts. Part 1 is signals, Part 2 is models, the systems. Now, till the last session, we concluded all the concepts on signals. Now, in this session, we are going to begin with systems. Let us start. Now, let us start. Just as we discussed in the previous concept, Unit 1, Part 1 contains signals, Part 2 contains systems. Now, the signals part is completed. The signals part is completed. Now, just we are going to begin with systems. Systems. Let us start. Now, before going systems, actually what is a system? Now, just look at a system contains a physical device. It may contain one or more physical devices which are interconnected to each other, or in majority of the cases may contain only one system or systems. Generally what we give input or inputs like this, input or inputs. Correspondingly, we are going to get outputs like this only. This is input, that is output. In electronics, we call input as excitation. In electronics, we call input as excitation. We call output as response. Response of the system. Response of the system means what? Output of the system. Both are same, but excitation, response are the specific terms of electronics and electrical, like that. Now just look at. This is a system, a physical device. So what is a system? A system may be a single device or a group of interconnected devices where for every individual excitation it provides an individual corresponding response of the corresponding excitation, that is called signal, so called system. For example, look at the input may be x1. Here it may go some transformation of x1 of t, transformation of x1 of t. It provides the corresponding response. We call it as y1 of t. Now just look at. Now if you give another signal, that is x2 of t, it goes under transformation, that is t of x2 of t. It provides a corresponding response, that is y2 of t. How x1 of t is being converted, not needed to know, but the output, what does it give? y1 of t, response. So for excitation x1 of t, response is y1 of t. For excitation x2 of t, the corresponding response is y2 of t. Now just look at the transformation is being done under this system. Now for example, students of CSE have to come to know that the same concept you already studying under software engineering. In the software engineering, just you are going to discuss black box testing, and also white box testing, like this only. It comes under black box testing. Black box testing is what? How the transformation is going on. The device can't tell us. We have to understand. We have to get only response only. For example, look at, take your calculator, Calc. This is called what? Calc, calculator. Now the function is x square plus 2x. Now you are giving the input equal to 2. What output it gives? 4 plus 8 it gives. For example, you get the input equal to 3. What output it gives? 15 it gives. Look at. As a user gives input to 2, but user directly gets the output 8. User may give the input equal to 3. User directly get the output as 15 only. How the transformation is going on? It is within the CalC only. This is called black box testing in software engineering. This is for your understanding purpose only. So now system is called, a system may be a single device or a group of interconnected device in which for every individual excitation there will be a corresponding response, that is called system. Now under this second part we are going to discuss about system and various kinds of systems in electronics. What is the impact of this system on signals? Just we are going to discuss. Here one more important point just we have to discuss. Now just look at here, these are signals. Here these are systems. These are systems. So these are called what? Excitation signals. We are giving what? Inputs. We are giving signals as input, excitation. So what we are going to get? Same, we get different signals as response. So input signals are different, output signals are different. The thing students have to know. So now so far signals are different, systems are different. Without signals, no system works out. Without signals, no system works out. Without systems, no signal is meaningful. Students have to understand again. Without signals, no system works out. Without petrol fuel, no vehicle runs out. No, without systems, no signal is meaningful. That is the interdependent. Signals are based upon systems. Systems are based upon signals. Look at, this is the interconnectivity of signals and systems. That's why for electronics and electrical people, the name of the subject that is called signals and systems. You can't isolate each concept from other. So now our main subject is called signals and systems. Again I am telling you, without signals no system works out. Without system or systems no signal is meaningful. There is no meaning to signal. That's why we are going to combining the concept of signals and systems under this semester. Now this is the concept of systems. Now just we are going to discuss various kinds of systems existing as per our syllabus is concerned. Now, as per our OU syllabus is concerned, there are 7 systems are given. 7 systems are given. Look at, the first concept is linear and non-linear systems. Linear and non-linear systems. Linear and non-linear systems. The second one is called static and dynamic systems. Static and dynamic systems. Now third one, casual and non-casual systems. Casual and non-casual systems. The fourth one is called constant time and varying time systems. Constant time systems and varying time systems. Fifth one, continuous and discrete systems. Sixth one, lumped parameter and distributed parameter systems. Lumped parameter systems and distributed parameter systems. Distributed parameter systems. Seventh one, analog and digital systems. Now look at. Now, as per our syllabus is concerned, we are going to discuss 7 kinds of systems under the sub-concept of systems. Again, just repeating that one. Linear and non-linear systems, static and dynamic systems, casual and non-casual systems, constant time and varying time systems, continuous and discrete time systems, lumped parameter and distributed parameter systems, analog and digital systems. These 7 systems now just we are going to discuss here. Now each and every one, wherever a mathematical analysis is possible, there we have to discuss for its complete analysis. Actually, let us start with static and dynamic, then after that we will discuss linear and like that. Let us start. So now just we are focusing on begin with static and dynamic systems. Now, the first system that is called static and next one is called dynamic. Static and dynamic systems. You know that a system is a group of devices, maybe a single device. What is a static system? Static system. If a system, here just the name itself, static and dynamic. A system, now just look at systems. In the first instance, we are going to differentiate between static and differentiation between dynamic. For your easy understanding, static means what? It is memoryless. Now, dynamic means what? These systems are memory systems. First thing, just you have to make it. Systems can be classified as differentiated as static systems and dynamic systems. How students have to remember this one? Static means what? Memoryless, no memory. Dynamic means full of memory, the difference. Now just look at the difference between static and memory. Now for just look at a system always depends upon the present value, but it cannot get the previous values. That is called static. For example, just look at, you have to make it y of t. Y of t equal to, for example, x of t plus x of t minus 3. Take this system. Is it static or dynamic? For example, put t equal to 0 or t equal to 1, present, t equal to 1. Then what will happen? Y of 1. Y of 1 gives what? X of 1 plus x of 1 minus 3. That means what? Minus 2. Actually on the scale, this is 0, 1, 2, 3. Going back, minus 1, minus 2, minus 3. If the system X of 1 means what? This is the present value. But X of minus 2, previous value. A system which depends, a system which depends only on present response but not on previous response. That system is called static system. This is the important property of static system. Now just look at in the example, what is the example of static system? Static system means x of y of t equal to x of t plus x of t minus 3 like that. So here the value, how to make it static or dynamic means what? Look at x of t equal to 1, substituting. Here it is present. It collects the present value, but it can't get the previous value. So that is the example of static system. Now just we are continuing the same in the next session. Thank you.